Okay, so with the first question, they are telling us that if we are given a number pattern, a number sequence, whereby the first term is 0, then we have -1, then we have 1, then 6 and 14. They want us to show that the sequence has a constant second difference. So in most cases, if we have a second difference, the sequence has to be a quadratic, or the pattern has to be a quadratic. So what we need to do, if we have 0, -1, 1, 6, and 14. So we need to first of all determine our first difference. And we know that in any case, for us to determine the differences, we can always get the second term minus the first term, or the third term minus the second term. In other words, we are basically subtracting consecutive terms. So if I have -1 minus 0, I'm going to get a -1. And then 1 minus -1, this is going to be 1 minus -1. It's going to give me a +2. Okay, and then what if I try 6 minus 1? That gives me a 5. And then 14 minus 6, I'm going to get my 8. So this is our first difference. And then let's try to see with the second difference. So still, we subtract the second first difference and the first, and then the third and the second, something like that. So it's going to be 2 minus -1, which gives us a 3. And then if we have 5 minus 2, that's a 3. And then 8 minus 5, that is also 3. So the whole of this is the first difference. And then the 3's will represent our second differences. Okay. Then 1.1.2, they're telling us to write down the next term within the sequence. So if this is a 14, and this sequence is increasing by 3's within the second differences, so if by 3, I'm going to have 11, and then 14 plus 11, saying 14 plus 11 will give us a 25. Okay, then 1.1.3, determine an expression for the nth term. So in other words, they're asking for the rule or the formula. In that case, Tn is what we need to determine. And since it is having two differences, then we have to use the approach of the quadratic, whereby this second difference will represent the 2a. So we can say 2a is equal to 3, and then we make a the subject. We shall have 3 over 2. We divide both sides by 2. And then the first difference is going to be represented by 3a plus b is equal to -1. So this represents the 3a plus b. And then we have our a, so we shall substitute this a in here, so that it is 3 times 3 over 2 plus b, which is equal to -1. When I simplify that, I'll have 9 over 2 plus a b is equal to -1. Then for me to get my b, I'll transpose the 9 over 2 so that it is negative that. And then when I simplify this, just put that in a calculator, I'll just have -11 over 2. And then my first term will represent the a plus b plus c. So I'll say a plus b plus c must be equal to my first term, which is a 0. So our a is 3 over 2. Our b is -11 over 2 plus the c must give us a 0. So when I simplify this, since the denominators are the same, I know that 3 minus 11 is just -8 over 2 plus c 0. We know that -8 over 2 is a -4 plus c will give us a 0. And then when we transpose the 4 to that side, it will become a positive. So c becomes a +4. Now, since the question is asking for the nth term, we need to write it or to rewrite the nth term of a quadratic, which is normally in the form of an squared plus bn plus c. So I'll put in my values. So that is a 3 over 2n squared. And then the b is minus 11 over 2n. And then our c is a plus 4. So this becomes the nth term, or the rule that is being asked for. And then 1.1.4, they're asking us to calculate the 30th term. So the 30th term is the same as T30 that we need to look for. Remember, from the previous question, we obtained the Tn. So where there is n, we're just going to substitute the 30. So that's going to be 3 over 2 times 30 squared minus 11 over 2 times the 30, and then plus 4. So when I punch this into the calculator, I'll end up with 1189 as my term in the 30th position. Okay, and then question 1.2. They're telling us that in an arithmetic series, that's a plus 13 plus b plus 27 plus, and the series continues. We're being told to prove that a is 6 and then b is a 20. So we need to know that for any arithmetic sequence or series, there is always one constant difference, only one, and it has only just one difference, not two like the quadratic. So I'll say if I have a plus 13 plus b plus 27, I need to get the first difference, and then that will be term 2 minus term 1. So that will be 13 minus a. And then for the third term and the second term, it will be b minus 13. And then this case is going to be 27 minus b. Okay. But one thing I know about the first differences is that they must always be constant or uniform or probably the same. So I'll first start with these b's, these elements that have b's, and equate them together. So it will be a b minus 13 is equal to 27 minus a b. Then I'll move this negative b this side, and then I'll move the 13 to that side. So when this b transposes, it will become, whole thing becomes 2b, and then 27, the 13 crosses the equal signs, becomes a plus, so it's 27 plus 3, which gives me a 40. And then I'll divide both sides by 2, so which means b is a 20. And then I come to n of this. I can choose to either equate 13 minus a is equal to b minus 13, or just replace this 20 into this and equate it to that. So I'll say 13 minus a is the same as b minus 13. Okay, but my b is a 20, so 13 minus a is 20 minus 13. Then 13 minus a is just a 7. Then I'll transpose the 13 to that side. Negative a is equal to negative 6, which means a is also a 6. So our a is a 6, and then our b is a 20. And then 1.2.2, they're asking us to determine the term of the series, determine which term of the series will be equal to 230. What is the question asking for? So in other words, they want us to find n, okay, where the Tn is 230. Determine the term, determine the position where the Tn is 230. So from the general term of an arithmetic, we know that Tn is a plus n minus 1 multiplied by d. Okay, but we know that our a is the first term, and then our d is the common difference, and then we're looking for the position. So since we got a as a 6, which means our first term is 6 as well. Okay, so this is a 6, And then we need to find the common difference, which we can say 13 minus 6, which is a 7. So A is 6, and then D is 7. And then we just substitute into that Tn. Okay. So where there is Tn, I'm going to put my 230 is equal to my A is a 6 plus, you can say n minus 1 times 7. So I'll start by moving this 6 to that side. So I know that 230 minus 6 is going to give me 224. Okay, 224 is equal to, I can still choose to multiply this into, or I can divide both sides by just 7. It's okay, let me just open that. Then I'll move that to be 224 plus 7 is equal to 7n. Then 224 plus 7 will give me a 231, which is equal to 7n. Then for me to get n, I'll divide both sides by 7. And then when that happens, I'll just punch that into the calculator. And then I get my n as a 33. So which means the term in position 33 will be 230. All right. So that is 1.2. And then next 1.3. They're asking us for which values of k will this series converge. So before we can answer the question, we need to know that for any series or any sequence to converge, there is a condition that must be fulfilled. And that condition is that -1 is less the common ratio and is less +1. So in any case, we need to determine what our common ratio is. And for us to get the common ratio, we can get the T2 divided by the T1. So I'll have my 1 minus k over 5 squared. I'm dividing it by 1 minus k over 5. So it's just the same element, but we have 2 of those ones. So which means our common ratio is 1 minus k over 5. And then I'm gonna represent or replace this back into the condition that is needed. Okay, so it's -1 less than 1 minus k over 5 is less than +1. So I'll start by eliminating this 5 through multiplication. Okay, so if I have this as a division line, automatically it creates a bracket in that format. And then I can multiply by 5, multiply by 5, and then multiply by 5. So this 5 cancels that. So then I have -5 is less 1 minus k is less 5. And then I have to move the 1 also, transpose it that side and that side. So since this one is a positive, the sign in front of it is positive, then I'm gonna subtract. So -5 minus 1 this side is going to give me -6 is less, I'll be left with a -k. And then if I have 5, I subtract a 1, I'll have a 4. Then I need to eliminate this negative sign, because whenever I'm getting the values in this format with this condition, I have to make sure that the letter is only left in the middle without anything else, not even the negative sign. Okay, so when I divide by the -1 on each side, remember, if we are dealing with inequalities and you divide with a negative sign, the inequality symbols will have to change. So that is a 6 is less than k, then is less than -4, which you can suitably write as -4 is less k and is less +6. So that will be the condition for which k, or for which that series is gonna converge. Okay, and then we have the next question, which is 1.4. In 1.4, we've been given 16, 3 plus 8 plus 3 plus 4 plus 3 plus 2 plus, and the story continues. 1.4.1, determine the sum of the first 40 terms of the series to the nearest integer. So someone needs to be very careful with the sequence or the series that is happening. It's like we have 16, then we have a 3, then 8, then a 3, then a 4, then so in other words, we have like 2 sequences in one. Okay, so there's a sequence or there's a pattern of just the 3s alone. Okay, the 3s will continue. 10, then 8, and then 4, and then 2. Okay, so since we have a uniform sequence of 3s, and we're talking of 40 terms, which means half of the terms or half of the 40 is going to be made of 3s, and then the other half will be made of this other pattern. So for the first case, I'll say 20 times 3, and then I'll have my 60. Okay, and then when I look at this pattern, 16, 8, 4, 2, it's like I'm dividing by 2. Okay, so if I try to get 8 over 16, that will give me a half, and then 4 over 8, that also gives me a half. So this is a geometric kind of sequence. Okay, then I need to remember that with the geometric sequence, the formula for the sum is a into, since our r is a half, then I'll have 1 minus r to the n over 1 minus r. We're looking for the sum of how many terms? That will be 20 terms. I'll do my substitution. I know that my a, which is the first term, is 16, and then my r is a half. So that is going to be 16, open brackets, 1 minus 1 over 2 to the exponent of how many terms are we looking at? The remaining 20. So we've used the first 20 with the 3s, and then the remaining 20 will be forming the geometric over 1 minus half. I'll just substitute, or I'll just punch this into the calculator, and it's going to give me 31.99. Okay, so this was for the first 20, this is for the second 20. Then I need to add both of them together, since both of them are forming the 40 terms. Okay, this is 60, and then that is going to give me 91.99. But since I was told to round it off to the nearest integer, this is going to be 92. Okay, and then 1.4.2, they want us to write this series in sigma notation. They want us to write that series within sigma notation. So sigma notation is just another form of representing numbers, but in the form of the sum, because sigma means sum. We are adding up things. They have told us that k or tk is the ar to the k minus 1, and a and r are basically rational numbers. So this is just the geometric sequence from that previous question, where we said our a is 16, and then our r is a half. Okay, so we need to determine what is the nth term. We said ar n minus 1, and our a 16, we're going to multiply this by a half to the n minus 1. So this is like the general term, which can be used to generate these numbers. But we can see that these numbers, they are reducing. They keep on reducing. In other words, they are tending to infinity. And in other words, we can say that these numbers are converging. Okay, so when numbers are converging, we shall say that we shall start from k being 1 up to k being infinity, because we don't know where this thing goes or ends. And then we shall insert our 16 times a half to the exponent of k minus 1. Instead of n, we're using k. So this will become the sigma notation. So usually whatever we feed inside the sigma notation is basically the formula or the nth term of the particular sequence or serial. And then 1.4.3, they want us to determine the sum to infinity. Oh Lord. Okay. So sum to infinity, we just need to know the formula, which is a over 1 minus r, where a is our first term, r is the common ratio. We still have them because the same question. So a is 16, then we said r is a half. So do the substitution, that is 16 over 1 minus a half. That will be 16 over half. Put that in the calculator. We shall get a 32. That becomes our our sum to infinity. Okay, so guys, that's question number 1. We have question number 2. Question number 2 is telling us that the graph is under functions. That the graph of f of x is given as a to the x, where a is greater than 1, which means this is an increasing exponential graph, and a can never be a 1. And this graph passes through the points 3 and 27 over 8. Okay. Then graph is drawn for you, there it is. Then they're asking us to use the graph or use the sketch and the given information to determine the value of a. So whenever we're finding missing elements in any equation of a function, we need to try to go back to the graph and determine at least a set of points. If we have 2 unknowns within the equation, then we shall need more or less 2 facts about the graph. But in this case, it's just one a that we need, so we can also just need one set of points. Okay, so we have f of x is equal to a to the x. We know that f of x is the same as y. G of x is the same as y. Is equal to a to the x, and then I'm going to substitute 3 and then 27 over 8. So 3 is for the x, and then 27 over 8 is representing the y. So 27 over 8 is equivalent to a to the exponent of 3. And then I will need to find the cube root. Okay, that 3 goes, I'll be left with a. The cube root of 27 is 3, and then the cube root of 8 is 2. So which means my a is 3 over 2. Okay, then 2.1.2, they want us to write down the equation of the f to the -1, which is the inverse. Okay, so the original was y is equal to 3 over 2 to the x. So whenever we write the inverse of an exponential function, it has to be a log function. Okay, so we know that within the logs, the 3 over 2 in exponential form is the base, and then it has to be carried to be the same base within the log form. So that is 3 over 2. And then all you do is just switch that. Carry the same base, whether it's an exponential or logarithmic form, and then all you do is just switch the x and the y. So this becomes the equation of the inverse. Then 2.1.3, they want us to determine the values of x for which the inverse is equal to -1. They want us to determine the values of x for which the inverse of x is equal to -1. So what this means is like we are getting the inverse, which is log 3 over 2 to the x, and then we are equating it to -1. Now, if I want to write this in exponential form, I will do that and determine what my x is. So I'm just going to switch the x and the -1. So I'll still use the same base, which is 3/2. So I'll say x is equal to 3/2, and then my exponent is -1. When I put this in the calculator, things are going to switch around. So my answer has to be 2/3. Okay, so that is 2.1.3. So even if this was a -2 or any other number, it's all about switching. So it's like we're moving from this logarithmic form into the exponential form for us to determine what is shorting. Then 2.1.4, if h of x is the same as f of x minus 5, this x minus 5 is a shift. It's like the graph is being shifted. The original graph is being shifted 5 units to the right. They want us to write down the domain. Remember, domain represents the x values. Okay, x values of h. So if I were to sketch this kind of thing, remember, the graph was passing through 1, and that was kind of the scenario. Now they are telling us that we are shifting this graph 5 units to the right. So which means the graph is somewhere here, but still passing through, the same points. So you're gonna pass through 1, yeah, somewhere there. Okay. So what this means that however much you shift this graph horizontally, nothing is gonna change about the x values. Okay, so the x values for this will be all the real numbers. So x is an element of real numbers, which means all the x values, whether positive or negative, will fulfill and satisfy that graph. Okay, that is 2.1.4. Then I need to look at 2.2. They want me to sketch, or they want us to sketch the graph of g. Okay, g of x, where x is greater or equal to 0. And this g of x is the inverse of k of x, that is ax squared, where a is greater than 0. In other words, a is a real number. So what this means is that if we look at the graph of g, is an inverse of this. Okay. So for a to be greater than 0, then that graph has to start from somewhere here and then move in that sort of direction. That is the graph of g, because we know that the ax squared is going to be a parabola, not an exponential. It's a parabola, which parabola is moving in this sort of direction regardless. So that will depend on what the value of a is, and then the inverse of it, basically where you switch. Okay, let's say if we have a x, and then we switch the x and y, so that's going to be x is equal to a, and then y squared, and then divide both sides by that, and then find the square root. So something like that. So this is more like a restricted parabola. So the restricted parabola will just be in that sort of format. Okay, something like that, because a is greater than 0. Okay, and then alternatively, we know that if the parabola is originally in this sort of direction, the inverse of it would be in that sort of direction. But since it's been restricted, then that will be the case that it will take, or the shape that it will take. All right, then question number 3. Question number 3. With question 3, we're being told that Where is it starting from? Question 3. They're telling us that Wendy decides to invest 12,500 for a number of years that we don't know, at a compound interest rate of 9% per annum, compounded quarterly. And then at the end of those years, our investment is worth this much. Calculate the value of P. So this is just plain compound interest. So it's A is equal to P into 1 plus I to the exponent of N. So we need to determine what our P is. Okay, so we know our A is 30440. Our I is 0.09 over 4 since we're compounding quarterly. And for how long? They're telling us for P years. For P years, N is P. And then our P, the original value, is 12,500. Okay, so our A is 30440 is equal to 12,500 into 1 plus 0.09, that's 9% over 4 to the exponent of, I can say 4 times P, which is 4P, because that is the total number of periods or quarters that were used. Then I'll divide both sides by 12,500, so 12,500 and then 12,500. So this will cancel that, and this is gonna give me 1522 over 625 is equal to, can say 1 plus 0.09 over 4. Don't want to simplify it, it's okay, to the 4p. And then at this point, for as long as I'm looking for exponents, or I'm looking for unknowns that are within the exponential format, I'll need to use my logs, introduce the logs on either sides of the equal signs. Okay, so that will be log and then log. And then from the second law of logarithms, I know that this 4p must become a coefficient. So it's gonna be like log of 1522 over 625 is equal to 4p into 1 plus, no, log 1 plus 0.09 over 4. And then I'll divide both sides by the log 1 plus 0.09. So my 4p is the same as the log of 1522 over 625. I'm dividing this by the log of 1 plus 0.09 over 4. Okay, I can punch that into the calculator, and then I'll divide my answer by 4, and then my P is going to be, just a moment, let's do that. So the log of 1522, the log of 1522 over 625, I'm dividing it by the log of 1 plus 0.09 over 4. Okay, that's gonna give me 40 point something something. Okay, 40,0000 something. So I round that off, then I divide both sides by 4, which means my P is a 10. So it takes me 10 years. So it takes this lady 10 years, not Wendy. So Wendy is gonna use 10 years to have that much on investment. 3.2, Susan bought a house. Susan decides to buy a house for 500,000 on an agreement that she will repay it monthly installments at the end of each month for a period of 5 years. Interest is charged at 18% compounded monthly. And they ask us for the annual effective interest rate. So these are things that were done back in grade 11. From the formula of effective rate, we know that 1 plus I effective should be equivalent to 1 plus I nominal over the n to the exponent of n. Okay. Then since we're looking for the effective rate, we'll transpose this one to that side as I do the substitutions. So that's 1 plus this 18% is our nominal rate. So it's 0.18. We are compounding it monthly, so we divide that by 12. Okay, and then this n will be a 12, and then I subtract a 1. Punching that into the calculator, and then subtracting the 1, I'm getting 0.19561 and so on. Okay, then I just need to round this off to 2 decimals after multiplying by 100. Remember, it is an interest rate, so multiply by 100, round off your answer to 2 decimals. So this is going to be 19.56%. So that is the effective interest rate. Okay, so effective interest rate is basically a type of interest rate that could be used without necessarily dividing by 12. It's like you just use it straight away as 100 out of 100 without necessarily dividing by 12 and all of that. That is 3.2.1. Then 3.2.2, they want us to determine Susan's monthly installment. So since she bought a house for this much and she's gonna be paying for the house, which means money will be leaving Susan, or Susan will be giving away money. So in that case of, or in that sort of scenario, we shall be using what we call the present value formula, since it's more like a loan that Susan got the house and then she must pay in installments, more like the house bonds and stuff. Okay, so we know that the formula for the present value, is P is equal to X, where P is representing our present value, and then the X is gonna represent our monthly installments that they're talking about. Okay, so it's X into 1 minus 1 plus I to the exponent of negative n. I'll divide this by the I. Okay, so from this formula, we know our present value. That is the amount that Susan needs to pay up, and that is the 500,000, which is the value of the house. X is what we need. Our I, we can use the 18, it's fine, which is 0.18 divided by 12. And then our N, the number of years, they told us Susan is taking how long, guys? Is it 5 years? Yes, 5 years. So it's going to be 5 times 12, and that's going to be 60 periods, okay? Or 60 monthly installments. Is anything else needed? X. Okay, so what I prefer is just make X the subject in the first place, then I'll do the substitution and all of that. So which means for me to get X, I'll multiply by I, which means my PI is equal to X into 1 minus 1 plus I to the exponent of negative n. Then I'll divide both sides by this big bracket. So my X is gonna be P times I over the macro bracket, 1 plus I to the negative n. Then I'll do my substitution at once. So that is 500,000 times our interest rate was 0.18 over 12. Then I'll divide this by 1 minus 1 plus 0.18 over 12 to the exponent of negative 60. Boom. Then what is left for me is to just put that within my calculator, within my machine, so that it can do wonders for me. So 500,000 times 0.18 over 12. I'm dividing it by the Makulu bracket, 1 minus, okay, that's 1 plus 0.18 over 12, okay, to the exponent of negative 60. So the answer I'm getting is 12,000, okay, 696,71. Okay, if I round that off to 2 decimals. So basically that's what Susan is going to be paying on a monthly basis, 12,696.71 cents. Then 3.2.3, what if Susan decides that no, she's going to pay 12,700 each month instead of the 12,696 as her payment? How much is outstanding after the 2 years? How much is outstanding after the 2 years? So the number of ways of doing this, okay? So you can first of all see how much would Susan have paid within the first 2 years. So number one, I can get, remember it's 5 years. Okay, that's 5 years that we need, but after 2 years, so 5 minus 2, which means 3 years will be the outstanding period. Okay, so I can still use the same formula of the present value and say P is X into 1 minus 1 plus I to the exponent of negative n. I'm dividing this by I. Okay, then where there is X, I'm gonna put my 12,700. Okay, into 1 minus, we know that that is 1 plus, we are still using the same interest rate. And then where there is n, I'm gonna say 3 times 12, that is negative 36. And then I'll divide this by 0.18 over 12. Okay, and then I'll just punch this into the calculator. So that is 12,700 into 1 minus, what's going on? Okay, 0.18 over 12 to the exponent of negative 36, close brackets. Okay, I'm dividing by 0.18 over 12. That gives me 351,290.69. Now that's 351,290.69. So this will be the outstanding value or the outstanding balance after the 2 years, for as long as Susan decides to pay 12,700. Remember, for this option, the second option, you need to get the value of the 500,000 in 2 years, and then you can use even your future, you use the future value to determine what is due in 2 years. Then 3.2.4, they're telling us that at the end of 2 years, the market value of Susan's house had reduced to 304,200. Now they want us to determine the annual interest rate of depreciation on the reducing balance. So we need to differentiate between reducing balance and the growth, or even simple depreciation. Okay, so our P, the initial value, will be the 500,000, and then our A is gonna be the 304,200. Then our N, they said after 2 years, they want us to determine the I. So the formula for reducing balance is P into 1 minus I to the exponent of N, to the substitution. So 304,200 is equal to 500,000 into 1 minus I to the exponent of 2. What did I write? Okay. saying into 1 minus I to the exponent of 2. And then I'll divide both sides by 500,000. Divide both sides by 500,000. So over 500,000. Over 500,000. So this and this cancels. I'll have 1 minus I to the exponent of 2. This is going to give me 0.6084 and so on. Then I can take square roots on both sides. Square root and then square root. So the square root of 0.6084 is giving me 0.78 is equal to 1 minus I. I'll move the one that side, so minus 1. I'm getting negative 0.22 equal to negative I. Divide both sides by negative 1. Or multiply both, divide both sides by negative 1. I'll have 0.22 multiplied by 100, which means my I is a 22%. Okay guys, that's where the revision of this paper stops. Thank you very much. Let's meet in the next session.